Hi guys. I just realized that I never really went over the scientist chart with you. I kind of just said, here, watch these videos. Read this if you need to. Um, so I just wanted to take a moment today and just kind of talk about each of those scientists. All right, we already talked a little bit about Tycho Brahe. I think I mentioned if you didn't watch that YouTube link on him, please do. Uh, it has a lot of great information. Um, but what we're really going to be concerned about today is kind of like how they contributed to the understanding of what our universe looks like. What was at the center? How do we orbit? So that's going to be the focus of today's lesson. Remember, Tycho Brahe um, was like the company church guy, and he believed that we were Earth centered. And he also believed that we did circular orbits. Okay. Um, and there was someone else who kind of believed almost the same thing that Brahe did. And if you remember from chemistry, this guy had an incorrect belief about the atom. And this, he was really super popular at the time, but he was also one of the church guys. So he kind of just said whatever, the church wanted to hear. And that was Aristotle. Aristotle believed that the universe all revolved around the earth. I mean, why not? We're like the most popular thing, important thing, right? And Aristotle also believed in circular orbits. Okay. Moving on to another scientist, we talked about Kepler. We did his three laws, and Kepler stated that we had the heliocentric. Sorry, its handwriting is horrible. Heliocentric, which was sun-centered, and he also believed in elliptical orbits. Kepler also said that we move faster when we are closer to the sun. But for the Earth, our rotation of the axis puts us, puts the United States in winter. We're facing away from the sun. So when we're over here in our orbit, this is where we are. But when we're here in the orbit, we're on the other side where you can't really, we're obviously the days are not long. The days are longer, but they're cold because we're not facing the sun. All right. After Kepler, I think, I'm trying to remember, I took a picture of it. There was, or in between them, there was Copernicus. Copernicus got one thing right. Copernicus got the heliocentric part right. He had the sun center. But Copernicus's biggest flaw is that he believed in circular orbits. But he knew something was wrong because the math wasn't adding up. He had extra time left. So what Copernicus did is he built in what we call epicycles. So these are essentially, even though we're not circular orbits right now, these are why we have leap years. It's to account for that extra time. So if this is the sun, all right, and we are going around it, and he's like, oh my gosh, we need to account for that extra time. The Earth would take like a little loop-de-loop, like a little, almost like semicircle, and then come back and like finish its orbit. So this right here, that was called the epicycle that Copernicus built in to kind of account for that extra time. He's like, yeah, let's just put it somewhere. We'll go in a circle again. So that was Copernicus. And you can pause the video at any time if you need to catch up. Next was Galileo. Galileo was essentially the opposite of Aristotle. And Galileo believed that we were a heliocentric universe. And because Galileo believed that we were a heliocentric universe, he had to hide a bunch of his research. He was imprisoned by the church and spent the majority of his life living an imprisonment by the church. He also had to smuggle out all of his publishings. His assistant would smuggle it out for him. And he didn't publish it until after his death. That's how much he went against the church. Another belief of Galileo's, and he gets this one wrong. He believes that everything revolved around the sun in a circular orbit. But what Galileo is famous for, also discovering the moon. And when I say discovering the moon, he makes a prediction that the moon revolves around the Earth like we revolve around the sun. And using a telescope, he's able to see craters on the moon. And so he determines that the moon is, in fact, made of matter, which was a bold statement at that time. And moving on our list, I think the next person that we're talking about is Edmund Halley. All right, so Edmund Halley is an astronomer. And what he does, he believes, one, that we're heliocentric. He believes in the elliptical, that's crazy, an elliptical orbit. And he charts the stars. All right, so he maps out the constellations in the southern hemisphere. And what Halley does is he kind of goes back throughout history, and he sees that civilizations have recorded this comet being seen every, I think it's 75 years. And the last time that Halley's Comet approached was 1986. Right? It comes back every 75 years. To date myself, I think I was either in kindergarten or first grade. And my teacher made a huge deal of Halley's Comet. It's something that you could see. It's not like a shooting star. It's visible in the nighttime sky for about 3 weeks. And what you would see is that the tail of the comet was growing. You could see it towards the end with the naked eye. You could definitely see it with binoculars, but our teachers went all out, like Halley's Comet pencils and Halley Comet erasers. So you could calculate that the next time Halley's Comet returns is going to be 75 years from now. So I'll let you guys do the math about how old you will be when Halley's Comet makes its triumphant return. So I realized I didn't do this scientist chart with you, and that's why I wanted to make this additional video. All right, thanks.